Okay, hello, welcome back to day number 2 of the Intermediate Android Marathon that's going on this weekend. So today's going to start out with the topic of databases, talk about database connectivity. Don't have to be a database expert. However, if you have some background in SQL, you're going to need it to write queries. You can't get past database fundamental skills, knowledge of what a table is, what rows are in a table, what a result set is. So if you're going to get into database usage in a widespread kind of way, you probably want to take a database class eventually if you're brand new to computer science or brand new to technology in general. This is not a replacement for a database class. I'm not going to really talk about database concepts. I'm going to talk about the Android system and how databases are used with Android, and then we're going to build one. So we're going to go through the first part while you guys adjust and settle in for our long day. You can listen to me talk for about 45 minutes or so, or half hour, depends on how long I talk for, and then we'll go ahead and build a project. So let's see, databases. It provides support for structured data. We can also use files, and we're going to see that as well today. So we'll write an app that uses just regular old files as well. Databases provide the support for the structured data as they do in regular database world. Nothing to install. It's given for us automatically on the device. So there's no API, there's nothing. You're automatically given to in a regular old project that you create. It's a collection of tables which are used to set different types of values. A database is a database is a database. Everything you're familiar with databases applies. We use a special language, SQL, for searching. It's the same SQL language that you're probably or hopefully familiar with. File representation for search algorithms to allow efficient retrieval. We make objects, pointers to objects, or no, I shouldn't say pointers, but we create database objects actually. Mechanisms to support transactions, and they create, most importantly, persistent storage. What I mean by persistent storage is that once the app is gone away, the life cycle's ended, it's closed, we still have data stored. It doesn't go away. It stays for until the user actually uninstalls the app. So it's from the install of the app to the uninstall of the app, the database automatically goes away. There's nothing you need to do for it. It's automatically created in the space and stored in the space that the app is taking up in the install folder. So the database is composed of one or more tables for those people who don't have a background in databases. But again, this is not a replacement for a full database class. The table is a collection of rows, values, and we have structured according to the types of the columns that we have. Here's an example of a student ID, student name, first name, student major, stuff like that. So the tables are the critical part. We're going to create the table, populate the table, read from the table. You do it all via SQL. So in some other situations, people use PHP admin. Like let's say, for example, you're configuring MySQL on a web server or Oracle. People love to use like web development tools like PHP admin and stuff like that, and they really haven't learned how to do DDL commands, data definition command, or create table such and such. So if you're missing that component, you can't just go to a terminal prompt, create a table, a populated table, read a table from an SQL perspective. That's when you probably want to take that database class. You can't rely on web development tools for this because you're not going to a website, you're creating it through Java programming inside of your app. So that's when those database classes will come in handy if you've actually taken one. Here's an example down here below where we have a key that is going to connect it, so all of the key concepts apply as well. Database tables in many ways represent tables or maps to data, class definitions and types, and they're sort of in an XML structure. They're saved actually in the app in an XML structure. We're using what's called SQLite. We're not using a full version of anything actually. It's a database concept. Implemented actually in the form of a file structure. So you think of it like Microsoft Access actually, but we don't have a DBF or DBF file. We have a XML file, but we can't edit the XML file like an XML file. We create it programmatically. So in many ways, database tables map to things such as here's a meal table with strings and doubles and IDs and rows and stuff. So as I mentioned, it's an SQLite database format, small, less than 300 kilobytes. Works off of a C library, actually. It's implemented, remember DBF? No, data, what was it? DBase? Someone remembered that? It's very similar to DBase. You don't have to remember DBase or know what that means, but it was before Microsoft Access came around. In the old days, we had DBF files. Or I guess Microsoft Access is what? AC something, or I don't know, file extension, MDs or something, or Microsoft Database or something like that. I don't know, NDBs or something. It's just the file. What I'm describing are the file extensions. However, there is no file extension and no file concept. We're working through a utility that's supported through an SQLite system. And the SQLite system actually uses files, is what I'm trying to say. So it's not a client-server database, it's a file-based database system. So embedded directly as part of the application instead of a client-server. So get rid of the client-server concept for the purposes of this. Is a much smaller scaled. Also employed on the iPhone, iPad, Touch, several MP3 players support this concept within Chrome, Mozilla, as part of Skype. Actually, Skype uses MySQL, or excuse me, SQLite, actually, as the database foundation. Database tools, 3 key issues that need to be concerned with. Creation of the database. You have to create our own database. And the creation of the database structure. Inserting and removing data from tables, and selecting data from the tables. So creating a table, 2 steps. We create a database file. We provide a name for the file. We use the API to create the file for us. So we have some calls that will be used to create objects, and then we'll write those objects. And then once we create the database, then we create the database tables that go inside of it, and we give that a name. Also requires specific attributes for columns. And both of these two are actually created in standard SQL scripts. So you need to define also a primary key, unique key, null keys, anything you could possibly imagine that you'd need for the database. So in this particular example, we'll look at a database for meals, as we saw in the previous slide up here. If we were going to create this one up here, and this is the one we're going to look at here, meals table, how would we write the DDL commands and how would we create this thing? So that's what this following example is going to go through for us. And what are we looking at? Not too bad, actually. In terms of creating it, we're going to, creating the database, here we go. We need a meals table, and this is going off of a previous example I did not cover last time, so don't worry about that. Let's just focus on the database itself, not the application that's reading it. We need a meals table. We need 5 columns in there, integer, an ID, a string, another string for the drink, a price for the double. The ID field is going to be our primary key. If that question had approximately primary keys for student databases, for U.S. citizens. Well, you think of it as the primary key concept. We'd use the social security numbers, or we'd use student IDs or something. We don't actually have any IDs here, so we're just going to make up an ID for the meals database. Just a table is going to keep track of meals, or what you ate or something. And if you were working in a restaurant, as a restaurant app, in fact, one of your apps actually works with a restaurant. You create a restaurant app. You can use a database for it if you wanted to, actually, store the stuff in there, which kind of lends itself well to this example. In terms of creating a database, what we have here is a SQLite database variable equals open or create database, and we're going to see this programmatically in a few minutes with an example, with a string name, integer flag on how to open it, and then cursor factory and cursor factory is parameters that we're going to take in when we open or create a database. It'll make more sense when we see it live, but what we're doing is just creating an object that's going to be the database variable, and it's an SQLite object that we're using for this. So here's the source code that would look like one for the restaurant. So creating a database for the meals example here, meals database equals open or create database, and we've defined previously that meals database is an SQL database. And so we're going to call it restaurant, and we're going to mode private with null. So we're going to limit the access to just creating the app. So no cursor factory, meaning that we are not going to be using any standard SQL cursor. cursor is when you query a database and you get the information that comes back out of the database. It's called a cursor. It's actually temporary memory. It's kind of like cached memory. You call it a cursor in database because you're constantly reading and writing to the cursor because you don't want to go back to the tables. You're never actually reading and writing to tables in any database. Actually, you're reading and writing from cursor information. So you run a query, the result set comes back. You get like a snapshot. And some people call them a snapshot, some people call them a cursor, but it's essentially the same thing. It's that cached information you're working with. This particular example is not working with one because we're just going to essentially populate it. We're not going to read anything from it. You can extend the cursor to develop your own handle results, to handle the results differently and get different things out of the cursor that's going to come out of it. We'll use a cursor in the source code example that we're going to build in a few minutes. So in the table creation, we need to generate the appropriate SQL statement to create the table. So the create table, if not exist table name, and then the syntax is a dialect of standard SQL. However, there's a couple of exceptions. There's a few things that are allowed. It's a little bit different. You can use a couple of different ways. You can create tables the old way with regular standard SQL, or you can do it with a newer way. Using kind of the shortcut techniques that are built into the API that are recognized by the SQL database package. Types, integers for integers, real for doubles, strings for text for strings. So the data types are going to be supported. In fact, you can go online and probably find SQLite database documentation. It's the same SQL database that's supported on the iPhone that's supported on other devices. So it's the syntax is the same. So it depends on the platform and the language you're writing it in, but a query is a query. So, but obviously, if you've worked with databases before, you know some database tables they respond to different types of. Let's say just talk about variable character for a minute there, and we have variable character, v character 32. We have different types of variable characters. In fact, some languages don't actually even support the variable character. They call it character. They call it string or text or something. So data types vary, so you do have to get familiar with what data types are here because what ends up happening is it won't recognize the data type. Well, I have to call it something else. But all databases in general will support characters, strings, numbers, floats, stuff like that. So when you ask the database to directly execute an SQL command or statement using exec SQL method is being used for that, which takes on a single string, which is the SQL statement. Here's an example of that. So we're going to create a string, and the string is going to be, this is our query by the way, create table if not exist meals with, and notice the syntax is slightly different. We're just going ID is going to be for the integer, that's the primary key, and the main is going to be the name of the table for it. It's going to be text, not null. There's a little flag we're going to put on that one. We're going to have a side text. So you have a main entree, you have a side. So this is going to be the side, it's going to be text, drink, text, and then the price for the meal. And then we're ending it with a semicolon, and we're putting that inside of quotes. So as if we were standing at an SQL prompt query command line interface, and we're going to type in this query. That's the query we're going to use. So here we're going to execute the query by going, this is the meals database that we created, and the meals database we created is going to be, well, here it is here. It's going to be the object. It's up here actually. We open our create a database. So once we've created the database, and then we're going to create this table inside of the database by running the exec SQL create string. This is the create string, which is going to be the string that's going to be used to create the table. So we create the object, create the table, populate the table, read from the table. Well, read from the table in any order that you want, actually. But you have to do the database creation first and then the table second, normally. So unless the database already exists, you can create multiple tables in one database. It's not one database per table. So if you put multiple tables inside of one database, you can link them together, use them in regular old SQL, regular old join tables, cross join, all that stuff. So inserting information into a table. When we insert information, it employs the insert method of the database class. So the database is stored in a context values object. And it is that object which is used with the insert. And so the context values here in this particular case is attribute pair driven. So very much like bundles and extras, because it's Android. It's working with a kind of a key value pair again. So let's take a look. So here in our meals example, we created a new context value object. Content values to insert. It's going to be equal to new content values. So content values, we're going to go to insert dot put. Remember the puts and the gets? Well, instead of put extras, we're going to just put, and there's no put database, so it's just put ID 1. So this is different. We're not using SQL for this. We're using the API calls, method calls on the database object to automate it. That's why I say it's kind of similar, but a little bit different than standard using databases out in other contexts. In fact, this is different than the iOS platform as well. But to insert, and then we're going to insert it after we've put it in. Yes?
It's not case sensitive, right?
It is case sensitive.
Column name has to be in the exam.
I believe that it is case sensitive, yes. Because we can have two IDs, a capital ID and a lowercase ID. We should have created this as a capital or as a lowercase ID, if I'm not mistaken. I think there's scripts up here. There it is. It is a lowercase ID. It's the lowercase ID. Well, it's kind of standard to put them all in lowercase, then you don't have to remember what they are. So that's what I do, is I just put everything in lowercase, and then just use the lowercase. But if you put hamburger in here with a capital H, it will come in with a capital H.
Yeah, that's
yeah.
value.
Yeah, that's the value, but the key is also case sensitive. So you create the new content value objects using the content value constructor here. That's what we did. And then we use the put command to store each one of the strings as a key. And then we use the appropriate value type that's associated with each one of the keys. So if we give it a number and it's a text, like in this particular case it's a number and this is a number, we have to follow that standard as well. You can also put in here like toString and converts. You could put, this could be the label. This could be a label, let's say that's on a form. You have a form in your app and the customer fills it out. You can do a, mylabel.getText. As long as it comes through as a string text, and convert it to a string if you wanted to do it that way. You call the insert function down here to insert into the database. So database name dot insert table, table name, meals, null, to insert. And to insert is this content values that we're putting in. And the content values is basically putting in a row. And then we're inserting a row. And then we're going to create another row, put that row in. Create another row, put that row in. So it's kind of tedious to say, it might be easier to do it with an SQL statement. You can actually do this with an SQL statement as well. But you have to know how to insert that way. So call the insert function on the database as follows, putting in the database name, meals database.insert. So you can actually put it in multiple different databases if you wanted to. If you had this content here, you had 4 tables, this would be a little faster than using SQL. Because then we would be saying meals database insert, customer database insert, and we'll put all the information, if it were appropriate, which ones we're going to put in to which table, depends on which we have in each one of the tables. But, to select information, we can select information and employ the query function on the database object. So it returns a cursor, as I mentioned before. The cursor is kind of the standard vocabulary used for the result set. It's essential. And an iterator over the values taken out of the table. So we use an iterator class to go through the cursor, and or an object, I should say, to go through the cursor, and basically follows the same pattern as the Java collections. If you were in the Java class, which we covered last time, actually it holds a reference to the values in the cursor in the table, and we can get an XXX method to extract data from the cursor. So the query function looks a lot like, this book page is from the actual book that this slide is coming from, which is the reference I gave you at the beginning yesterday. It's also at the beginning of this lecture if you want to look at it. Otherwise, it looks very similar to this up here, which is what that's referencing to. But it's a Boolean indicating whether or not only unique answers are going to be given, whether or not the string name of the table to query is going to be provided, the projection or the array of strings that's going to be put in there, the where clause, the group by, the strings. So the query itself can contain all of these different parameters, and we have a ton of different parameters that can be executed in the form of methods that are going to be on the object. So besides the first two, the others are left to null if you want, to make it more efficient to retrieve and to add things in. The where clause is how you're strategically going to define what you want to get out of the database, which is kind of interesting as well. So let's take a look here at some of the methods. So in terms of the information from the cursor has the ability to scroll back and forth through next or previous, ask about the state of the cursor in the results, and then access the data in the results. So we can move to the first, move to the next, get count, get column name. So the cursor, it contains not just the results set, it's not equal to a result set. It actually has the metadata about the result set inside of it. If you've worked with the JDBC, this is exactly the same. So, but some of you may not have worked with JDBC yet. It's the cursor, it's the same concept. This is written in Java. In fact, this is an extension of JDBC. So it's actually kind of a lighter weight version of it. But we had to execute query, execute, there's a couple of different execute statements for query when you want something back versus don't get. Execute statements, prepared, and then sending things. It's the same concept that you can do over and over again. It's not JDBC, however. It's a dialect that's very similar to it, based upon, well, probably written by similar developers, I would almost say. So it's very similar in nature. Retrieving all and printing out the all but the index data from the mules database. So we have cursor. So we're making a new cursor object instance, and we're going to call it return values. And it's going to be equal to the mules database. And here's the interesting part, .query. What are we querying? Well, these are all of those fields up here that we're setting, some of them to null, some of them not to null. So most part we're going to set them most to null. We're going to query meals. This is going to return back everything for us, actually. And then the return value is .move to first, which means set the cursor index to the first row that was returned from this is equivalent to basically a select star from meals kind of query. And then we're going to create a string, meals, that's going to be equal to get the string from return values, which is the cursor, .get column index main side. So we're going to get all of these guys, and we're just going to print it to the screen. So after we populated the information with these guys up here using a put and taking the content values and then inserting it into the Mills database, we're simply coming back over here and doing the opposite. Querying and getting everything that's in there using the query. Because these are all set to null, we're just going to get everything. We're not going to sort it by anything. There's no where clause, from clause. And there's a from clause. From clause is right here. But there's no where or distinct or any of those other switches that we're going to get. And if you want to know, just basically print out or look at this list here, and you'll see all of the different. And this is basically an SQL query broken out into different components as used as parameters for this method call. And it's a basic select with all of the group by, having, all of those different options you can put in a select clause. And so now we have the output.set text. Well, that's probably going to be an edit text box or something, or a label that's going to be on the screen. Set it to get text, and then paying this price for this meal. And then while return values move to next, which means if it's true, returns move to next means it's when it returns true, we're going to continue. Otherwise, when it's false, we don't have anything next. We've hit the end of the database cursor.
When we are seeing the get column index, we are not getting the value, right?
No, we're getting the column metadata that's coming out of that. Because the cursor is not the result set. So when we think of, when most people think of cursors, they think of, select star for meals and you get like this dump of the information. The cursor is a formatted key value object that's coming back that says ID 1, meal, and then it says hamburger, or whatever we put in there. And when we get the column index, we're getting the number 1, number 2, number 3, number 4. There's an order. There is an order actually in a cursor for another database, for Oracle as an example, or MySQL. There's a column index for how the result sets are retrieved back. It doesn't match the column index of the columns in the table. It's the index of how we retrieved it. So if I said select star from this table where meal is equal to meal, or select main from this table, I'm only going to get one index because I'm going to get main that comes back. So on the select, our index is going to be 0, 1, 2, 3, 4, depending upon which fields we're returning. And when we get the column index, we're getting 0, which is going to be ID. This particular, I think it's going to be ID. Should be, or maybe it's main in this particular case, because we're, I don't know the order that these are in, but long story short, it's going to get the metadata for the column of the first entry, the second entry, third entry, which is what the column index here. But it's named because we're getting the metadata. So instead of calling it main, or 0, 1, 2, 3, we can also get it by number. But we can also get it by the name, and this is using the column index by name, main, side, drink, price, which is the metadata about the column. So it's not like exactly like in a results set that comes back, nor is the cursor from JDBC. It's actually run the same way.
What makes, in this syntax, what makes the program to get the value? Metadata is data about data. So what gets the value?
Return values method. Return values, which means instead of keys, you can return the key, you can return the value. And if you return the value for column index main, it's going to be hamburger, I think, actually. Because the first row that came out of here, I think, was hamburger. Actually, I don't know what else was in this meal plan. Up here it goes, hamburger, french fries, and a Coke. Chicken. I want the cheeseburger now. Let's see. It's not even lunch yet. So, what do we got? Oh, I think I left it here. Here we are. So it's going to come back with whatever the main was, which was going to be hamburger. That's how we're getting the value.
So what is the purpose of get string method?
Get string converts it to a string. It's the get string method.
So return value will be type of object, or
The return method, return values,
so it won't be a string?
it's not going to come back as a string. What if it's an ID? It's going to be a number. How do you know it's going to be a string? You have to use, actually a string is a string is a string, not really a string in Java. You use the get string or toString, depending upon how you're designing your method. The get string is going to basically convert it to a string. A toString does the same thing. Usually you write your own toString and you use a get string. That's going to be an automatic conversion from a number or a floating point or something. Or a string in the database is not equivalent to a string in Java. So it converts it to a Java string. Because we have a string here. We could typecast it with string in there if we wanted to as well, but we have a get string method that's part of this object, this return values object, which is our cursor. The cursor has a method in there to get the string. We can also get integer, get float, get double. So it depends on what value we want, because we don't have to necessarily put this in a string. We're putting it in a string right now, but we could put them in a number. We could be getting numbers out of the database and using them as numbers, and we get integer in that case. Get doubles right here, actually. Get double.
And what the output you set text and get text to?
This is going to be something on our UI. We have a text field that's going to be called output, perhaps, and then we're going to output. We're going to set text, and we're going to set the text to output view. Which is get text, which is the current text that's on the label that we might be having out there, plus, and we're going to concatenate this stuff to it. Yeah, it's a strict concatenation of what's on there. So we can get a whole price list of everybody who's in there. Yeah, these are really good questions, by the way. Any other? Okay, good. We'll move forward. So only print main components of the meal over $4. Ooh, so we're going to change the query now to, this was getting everything. So let's get the meals that are over $4. So if we do that, we're going to use the where clause, where indicated by the rows where the price is larger than $4. So we're going to use the order clause here indicating the price in a descending order. Same standard SQL, but we're putting it in a Java syntax. So, and then the project onto just project onto just the main column. So this is where I said before, we can say which columns do we want. So in our column, we're going to have a main that's going to come out. That's going to be a string array that we're going to introduce here as a column of interest. And so now we're going to say that the return values, because we're still using the same database object here, is going to be equal to query. Same thing as before, but we have meals in here is the name of the database. And then column of interest. Column of interest is going to be kept in terms of the columns, the meals, that where the price is larger than $4, no, price in descending order. So it's kind of a combo of, well, this is syntax for SQL, so it's kind of a combo of, we're getting prices back out here, and the prices are going to be in descending order, so it's kind of like SQL, but it's not. It's written in parameter lists for a Java method call. And then the output, we're going to set the text, and then we're going to move to the first. This is the same code as we just looked at a few minutes ago, except we're going to get the column main that comes out of that for the main entree. So, and we're still not specifying which columns we're getting. We're just getting all of it out of there. But we're going to put the column of interest, which is going to be the price descriptions of everything larger than $4.
Actually, I forgot to ask the same question above syntax as well. In the return values, we see lots of nulls.
That's because we're not specifying. If we go back to this list up here, anything, here's the query function. This is the query function where we've been looking at. The first one is going to indicate only unique answers. Well, we'll say that the false. We don't want to put distinct or unique on there. We want everything is going to be false. So then the next one is the one we're seeing all the time. It's going to be the name of the table that we're going to query. And then, so that's why I said this here you're probably going to print it out or make a little note to yourself. Because there's like let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 different columns. We don't want to specify it. We put null in there. 9 different parameters that we can send this query. But do we really want to use all of them? Well, we're going to use the where clause, the group by clause, the having clause, and then the projection. So it's going to be the array of strings. This is going to be the list of columns of interest. That's the third one down. So the column we're looking at in this one here, 1, 2, 3, was everything because it's null. And this one here, we're looking at 1, 2, 3. Oh, the price larger than $4. So it's like saying select price larger than $4 from, which is what we're going to get as our column.
We can put more than one condition.
Oh yeah, I can. As long as it's in between the opening and closing quotes, it's going to be substituted in as if it were pieces that you're going to put into a query and run the query. So just imagine a query dissected out into parameters, and those parameters are being sent as a method call now. Other database commands. We can update. This is a query to basically retrieve data. We can also update, change, create content value, stuff the content value with what we want to update. There's a space in there. Use a where clause to indicate what rows to update, and then we can call an update function. So this one was a insert function. No, this was a query. This was a query we just did. So now we have meals database.update. Same as before, same order as before in terms of the parameters. So, but actually, let me rephrase that. Not the same order, takes on different than, we don't, when on an update, we don't normally do a where clause. Actually, we do a where clause, but we may not necessarily have all of the other ones. Update this field, update that field in the beginning of the query. So here's kind of a scenario in terms of it's very similar to the insert actually, where we have the content values to update is equal to new content values, and then to update.put main McChicken. This looks like McDonald's actually, and then meals update.update, and then we have the meals database table to update. It's the content we're going to put in here where main is equal to chicken sandwich. So we're going to change chicken sandwich to McChicken in this example. because we're going to McDonald's, I guess. So. Here's another example, deleting rows. So everything you can do in SQL, you can do with these method calls. So to delete a row here, you're going to go use .delete. This one was .update versus .query. All in the same database object, and you use the same database object you created initially. So it provides a where clause in this particular case, indicating that you're going to use a database variable .delete with a string name and a where clause for where you're going to delete, because you're not going to delete the whole thing. So here you're going to, in meals, you're going to delete to where the ID is equal to 1. So that's the hamburger. We're going to take the hamburger out of there, probably put tofu burger or something there instead. So, big picture, most of the database functions are just abstractions or parts of SQL language. So just remember that when we start looking at these things. It's just an abstraction of SQL being put into menus. So. Let's see. A little bit more on the retrieval and the printing. We did that actually. So there's a little bit of overlap in these here. So let me just see if there's a new part coming up at the end of this one. Deleting a row is where we sort of left off. And the big picture is where we left off. So saving data on the phone. So we're using a database as a structure with a SQLite. We can also save in other forms. Databases are just one way of storing and accessing the information on the phone. It may actually be overkill for a small and non-complex application. We're going to actually create a small non-complex application using a database, and we'll kind of see how it is. We can also use what's called shared preferences, and which is similar to the same preferences that we get on the iPhone. And then we can also use a file system, read and write to files. So I'm going to leave this one here, talk about shared preferences. But before I do that, I want to go through the database example. So the database example that I have, oh good, this updated. So in the background I was updating my Android, getting that ready to go. So I'm going to actually close this down and open it back up again. So go ahead and start up your Eclipse. And on the database tutorials, we're going to run through this one first. And this one is going to be located, for those few people, it's a step-by-step one. So we're going to build this one, and then we're going to look at a couple of other ones that are already built. But I want to build one first just so you can kind of see the abstraction of how it's put together. If you go into the Android phone application development, into the course materials link down here, and you look under tutorials, the one we're working on right now is at the bottom of this list here, and it is called it used to be at the bottom of this list here. Well, unless I moved it. It's possible that I moved it. Yeah, do you see it in this list? I should alphabeticalize. At database tutorial and solution way up here on the top. I probably should stick this in alphabetical order. I try to stick it towards difficulty. The ones on the top are easier than the ones on the bottom. So this one's pretty easy. It's on right next to tic-tac-toe, actually. So this is the one we're looking at right now. There's another set of examples if you're bored and you want to download something. And you go to course materials. It's going to be in the supplemental notes section. Let me go back here so I can find it. I clicked on the course again to go back at the main level. Supplemental notes is what we're looking at here. And this one is a very old database example, and it's right down here. It says database example on it. It's a zip file. There's no tutorial that goes with it. It's just a zip file. Slightly different perspective, older style. So we'll take a look, and both of them are slightly different. So it's kind of just the same ways with the intents. There's different ways of creating databases, actually. So kind of interesting how this works. So go ahead, open up Eclipse, and let's just build this one from scratch so we can see what we're going to work with. And it helps to put things into perspective as well. So let me take that one down. I thought I had this one opened. All right. So this one's going to be a simple cut and paste, and we'll talk about it a little bit. This one's going to use a database handler as well. Yes?
So when you say older style, you mean older or maybe SQL syntax?
No, actually, both of them are going to be using SQL syntax. I have another example that's not going to be using it. What I meant by older style is it was created in an older API that didn't support. So in the beginning, the earlier APIs didn't support all of the object methods, and we had to do a lot more SQL. The older one that I called older is very old school because it's all done with query. It's all the queries are done the same way, and it's just doing a query. Query after query after query, and it's actually sending a raw SQL query to it. The newer ones, and this example here isn't going to do that either, but there are different variations. So as we go through it, I'll answer your question again. But it's until you see it, it's really hard to compare to see what you're looking at. So we'll take a look, and then I'll answer your question one more time later on, because then I'll have something that you can compare it with. So in this particular tutorial, we're going to create one here. I'm going to create a project called a database. It's going to be a regular old Android project. So go ahead, open up Eclipse, go to File, New, Other, and let's call this one a database project. Database. I'm going to call this one Database 1 because I'm going to load in another one actually. And what happened to my wizard? Yes, it's going to be an Android project, Android application project. I updated my Eclipse, so I have a strange feeling it's reset my, okay. I have to wake up, I guess. Android project. Click next. I'm typing in the name of it already. Okay, so it's me. I haven't finished my coffee yet. Okay, database 1. Speaking of which, I'm going to go sip some. Alright, I'm going to change my path because I like to do that. You can leave your path alone. It doesn't really matter what you use for your path. I'm going to put mine down at the bottom of the 2.2 Froyo just because I like to run it on my other emulator that supports it. So, and I'm going to go ahead and press next, and next again, and then next again. And leave the main activity as main activity. And go ahead and press finished. And the database will run on the emulators. It will also run on the device as well. So you don't have to worry about device support. It's not like the sensors and stuff. We will be looking at sensors later today as well, but this is kind of universal to run on everything. And I see I have some suffering in the background because I immediately have a red little thing going on here, which means my system has to catch up. And the red mark will go away. If your system does that, it means that it's, yeah, there we go. It hasn't saved the r.java file yet, so it's in the process of configuring itself, storing itself in the workspace folder, and saving all the files. And it turns red because it's not ready yet, which looks like an error message to me. If they just delayed the showing of the project until it was ready, I think that would be a better UI for it. But because it convinces people that, oh, there's something wrong with the project, but I just created it. And depending upon how slow your system is and what you have running, it might take like 2 or 3 minutes, and then people are like trying to delete stuff and play around with it to get it to work when you just have to wait. So yeah, I'm sure I've actually had a couple of email messages of people going, I create the project and immediately it doesn't work. Yeah, it's not my fault. It's your computer's too slow. Alright, so we're going to create a new class. So this is what I'm going to show you is kind of the typical way of organizing it in a fashion where you've got a database helper. So instead of hard coding and putting, and this is, okay, going back to the intents we looked at the other day, this is kind of like the intent helper class. Also kind of like, was it the intent? I'm not quite sure. Yeah, it was the intent that we were in for this. Passing and sending, so databases, if you create a database helper class, you can take the class and reuse it in all of your database applications, and it all does the same thing. It just helps you work with the database, and then it's going to include all of the database functionality for us. So, and here we're going to create a new class object, and we're going to name it database handler, also referred to sometimes as helper. And in another example, I call it helper because a helper is sort of a handler helper. And it's going to be just like any other ordinary class. So go ahead and create a class, and we're going to stick the class inside of the same folder as our main activity. So I usually just go to the folder, and then I'm going to go File, New, and then I'm going to select Class, and I'm going to call it Database Handler, and I just pasted it from the PowerPoint, so I pasted it in here. Don't worry about putting in anything, because we're going to replace the contents in there, so don't worry about what you're selecting here. Just go ahead and click on Finish. Whatever in there is going to be taken out anyway. So now it opens up, and I have the Database Handler. So let's take a look to see what the Database Handler is going to do for us here. So the Database Handler, actually, let's just see what kind of issues I'm going to run into when I go ahead and cut and paste the code and stick it into the Database Handler class. We're going to use a spinner, actually, with this example. So I'm going to leave my package on the top, but I'm going to replace the code with the code that was cut and pasted from the example. And there we go. Reformatting the code with my Command-Shift-F. You need to write that down because I'm going to forget it as soon as this class is over. So let me talk about what this database handler is doing. So what we're looking at then is database handler that's going to extend SQLite Open Helper. So Open Helper is an automated way. It's an interface that's, it's a class that's created that is included. So if we look up here on the includes, we have database cursor, we have database SQLite database, and this example is using what's called the SQLite Open Helper, which is another area in the hierarchy. It's a little bit higher up. It's a little bit easier to work with because we're creating what's called a database handler or helper that's going to basically extend this functionality, automates the process for us. So what do we have here? We have some database name, which is going to be database version, which is going to be equal. Well, we're going to specify the name here. It's going to be spinner example because we're going to use a spinner to populate it with information that comes from a database. And then we can select stuff from the database. In this particular example, we have another one that's going to do something a little bit different as well. So here we have a integer that we're going to keep track of the database version. We're going to call it 1. And this should be line returned here. There we go. So the database version, we're going to call this 1. Why are we going to keep track of that? Because what happens if we upgrade our app and we change the database format? So you're writing this beautiful app that you've designed, and you've designed this table for it, and you don't give it a version number. You just say, hey, here's the table. And you make some modifications to the table. And then you update the tables, and you change the format of the tables. And then someone goes to Google Play and says, hey, I want to update this app. This app's changed. Wow, we got a new version of it. They download it, but they don't, and the app is still using the old database table, but we have new fields that were added, and the database was modified. So if you keep track of the database version, you can update the version for the user, because they're going to update, once the table is created in the database, it's in the app, then they go and they update the app. And then, oh, we have a new feature, and the table's changed. But they're using the old table, and then the app's going to fail, and you're going to have terrible troubleshooting problems. So if you keep track of the versions of each one of the databases that you've created, then you can go, what version of the database? Actually, the software itself can check it programmatically and say, oh, no, delete that database, recreate it. Because it's like a file. If the file exists, don't create it. If the database, don't create it. Well, if it's there, but it's the wrong version of it, it's going to cause a problem with the app functionality because this is reading and writing to something that expects to be there. So that's what the version's about. Okay, the name's going to be called spinner example because we're going to, you could probably call the project spinner example. We're going to put a spinner in here. It's twofold. And then the labels is going to be the table name. So the table names is going to be called labels. And then the column IDs, we're going to have an ID and we're going to have a name. So only 2 fields in this, and they're both going to be strings. One's going to be an ID, key ID, one's going to be key name that we're going to stick. So it's a very simple database. Here is our constructor for the database handler. It's going to take the context and it's going to run the super context database name, null database version. Database version is going to be 1. So when we create it, we're going to create it using the constructor. We'll see that when we implement the code. So we're going to do a little thing here for the onCreate method. So when we make an instance of database 1, in this particular case, because this is the version number we're sending it. We're going to do this. We're going to say create a string, and the string is going to be called create categories table. It's all in caps, which makes it kind of hard to read for some people, but this is the name of the string we're doing. It's going to be equal to create table plus table labels. Table labels. And key ID name. So it's made generically, so you can use this database helper with multiple different classes to create multiple different tables with multiple different fields with keys and stuff. This one only creates 2 because there's a key ID and a key name that goes along with it. But then that's the label. And then here's where we're going to do an execute SQL. Very JDBC-like, actually. And what we're going to execute SQL with, we're going to run that command to execute this string, and the string is going to be a query. So usually people who are first learning this can, if they've had any database background, you can understand what a query is doing. So this example is just executing queries, not using any of the methods that go along with it. So this one here is just going and execute SQL. And then on an upgrade, because what ends up happening is we have database upgrades. The database is handled by the operating system. The operating system gets revised, and we have a 2.2 version, a 3 point, a 4 point, a 4 point something now. And the database keeps changing. So if you're going to upgrade it, if you're going to keep the old database style, it's not going to work. So you have to upgrade the database. So there's a method in here that actually checks for an upgrade. So when the database helper is being used and the object gets created in your class, if after on the onCreate you're creating the database, we're going to check to see if there's an upgrade. So on an upgrade, it's taking in the database, it's taking in the old version and then the new version. We can update the database, not from, well, we can do it 2 ways, from an operating system update, to update it because the operating system's changed its formats, which might affect it. Not necessarily a problem, it's usually when we've changed it in the app. As I was mentioning before, now we have version 2 of the database. Now it has a new field in it, so we can update it. So we can run the onUpgrade method to drop the older table if it exists, and then recreate the table by creating the calling the onCreate method. The onCreate method here is going to create the tables, given the information that we've passed to it. And what are we passing to it? We're passing a database object to it. Where are we going to create the database object? Well, that's going to be out in our main program. So the database object gets created out in our main activity. We send the main activity. The main activity sends to this database helper. Here's the database I want to create. Can you create it for me? Can you upgrade it for me? Can you do all this stuff for me? And you don't have to reinvent the wheel every time you write the code. It's separated out into a separate class for functionality purposes. So what are we going to do here? We have an insert label, and then we have another one here, get all labels. And these are methods that work with the table. There's only 2 of them, insert and get. So in the insert label method, we're going to create this.getWritable database. We have this object knows of a database. We're going to copy it into this SQLite database called DB, the same parameter or name we used on the onUpgrade, and then the same parameter we used on the onCreate. We're going to put it in here, but what we're doing is we're inserting a label. So we're going to take the string for the label. We're saying, okay, put a label in here. What do we have? A label. When we insert something, we have 2 things. We have a label, and then we have a key. So we have 2 items here. We have the key ID and the key name that we're going to work with for column names. So this database helper allows us to insert a label. And what we're going to do is we're going to set the contents value. Remember the content value, the values. And we're going to put values.put. What are we going to put in here? The key name and the label. The key name is going to have the label that we sent it, and the label is coming from the parameter call. And then we're going to db insert the content labels null values. For the labels, we're going to put the values in here. And then we're going to close it. db.close. Does it close the connection? Yeah. Why do we need an open connection? Nobody ever has an open connection to the database. If you have an open connection to the database, it runs slowly. So when you connect to it, open it, close it, open it, close it, open it, close it. It's kind of like what you do with JDBC actually too, unless you are trying to do something special with it. So here's a method to get all of the labels. You might call the labels fields actually. And it's going to return a list that is going to be holding strings. And this is from the list container from Java container class or package. Get all labels is the name of our method. And we're going to get here a list of strings. That's going to be a new array list. This is why you want to take the Java class, because you can learn about all these fancy container classes. Select all query. So we have a string that's going to be the select query. And the query that we're going to run is going to be select star from table names. Table labels, excuse me. And then after we've done that, we're going to create the get readable database. We're running a get readable database off of this. This is our database object that we've created that we've given a database name. So we're going to create a temporary one here called a DB. This is our SQLite database. Then we're going to create a temporary cursor object to work with. So cursor is going to be equal to db.rawQuery. Get the raw query, which is going to be our cursor result that's going to come back. So select query, this is our select query. So run the query, take the raw query, copy it into the cursor, and then let's move through the cursor. And when we move through the cursor, this is the same thing as we were doing before. We're going to move to the first. The loop has been set up so it goes, if move to first, which means we got something. So it's a little bit better actually in terms of the design, rather than just move to first, assuming we got something. If we move to first, we got something, then what are we going to do? We're going to do labels.add, and then we're going to use a get string here on 1, as I mentioned before. So you can use the index values, or you can use the names. So we can get the context ID, and in our other case we called it main. I don't know what we're calling it here. We don't know what we're going to call it here, actually. Because we could label it anything we wanted to, because we didn't make it here. So we're going to use the index value, and it's going to start, I'm going to jog my memory here. I thought it started with 0, but I guess it does start with 1. While cursor.move next, it's the first, it's the first value in the index is what this is in the row. So we're going to get, the first one's going to be the key 0, the second one's going to be 1, which is going to be the value that's associated with it. We're getting the values out of the labels. And there's only one label in here, so we only have to worry about the first one. It's for a key label or key value combo. So that is right, it does start with the values of the index does start with 0. So close the connection, cursor.close, close the database, database.close. Return the labels. Labels is going to be a list. It's going to be a list of strings that's going to come out of here. So what we've done is we've dissected the database behavior, stuck it in a database helper, handler, extended the database SQLite open helper, which is going to do our opening, which is going to be our onCreate. So let's see what else we need to do changes-wise. We're going to create the spinner drop-down. So open up the XML file for the main activity and create a spinner drop-down using the following XML code. You can actually drag and drop and put a spinner on there. Also in the following code example form, we're also going to create an edit text. So we're going to put a text field in there too. So I'm just going to do this because I'm lazy. I'm just going to cut and paste the XML code because I don't like working with that interface. So let's see, I'm going back to the project. And I'm going to close my database class because database handler is done. We're going to leave that one alone. Now we can reuse database handler in any class that we want to, any project that we want to do these database activities in. So I'm going to the layout, resource layout folder, and I'm going to click on the main activity, and I'm going to go into the XML interface. I'm just going to paste in this code here. And then I'll press the Control-Alternate F to reformat it. And we're looking pretty good. So what do we do here? We created a linear layout. And we have defined the label, and the label is going to be a text view, and it's going to be add new label, and then we're going to have an input text, which is an edit text. So we're going to have the ability to add a new label. So we have a name for the label, then we have a spot to put the label name in there. I'll show you the visual in a few minutes. And then we're going to have a button on here, probably says add on the button. And the button says add label. And then we're going to have a selected label. So it's going to show us which one is selected. And then we're going to have a spinner, which is going to be a drop-down list. And the spinner is going to essentially show us what's in the database, because we're going to populate the spinner with the query results. So if I click on the graphical layout here, and I zoom in a little bit so you can kind of see what's on my screen, it sort of looks like this. We've got, let me get rid of this down here. Zoom in a little bit more. See, it was easier for me to cut and paste it than it was for me to actually put this in here. So to drag all these items would have taken longer. So that's our label. There's our edit text here, and we have our button along with which item was selected. And then down here on the bottom, we've got a spinner item. And the spinner item is going to contain the items that we're going to pull from the database. So what we're going to do is we're going to add items into the database, and then we're going to see the items show. These are just generic items, by the way, so really no big theme going on here. So not to get messed up with a theme. So once you're satisfied with your user interface, and like I said before, cutting and pasting and putting that XML code in there just saved me about 45 minutes worth of design work. So I'm going to go ahead and save it. It's good for me. And if I do that as well, then I can use the same IDs that are in the PowerPoint. So I highly recommend, for the purposes of these exercises, just cut and paste and put it in. You can spend as much time as you want building it on your own. So now we're going to open up the main activity, and we're going to try the following code. So what are we looking at? We got the load spinner data that's going to be called on the onCreate. And the load spinner data is going to be a method that we're going to write. And the method's down here, so I'm going to explain it before we put the code in here. So the functionality is going to work like this. So we have the onCreate method that's going to load the spinner data. Well, how's it going to load the spinner data? Well, it's going to look for the SQLite database. If it's not there, it's going to create one and then load it up empty, because it's just going to create a blank one. And then open the add button. Once the add button is clicked, a new label is going to be inserted into the database. After new label is inserted into the database, again, the load spinner data is going to run again. It's going to load the spinner data into our spinner. So it's called to load the spinner when a newly added data from our SQLite database is created. So the code itself is not that interesting. It's a main activity that's going to extend the activity that implements an on item selected listener. Remember the listeners from yesterday. And we have a spinner element, spinner. We have a button, button add, a input text for edit text, and then we have our onCreate method. Our onCreate method is going to essentially set the context view to the main layout, which we have already. And then the spinner element, we're going to find the spinner that we stuck on the XML and assign it to the spinner variable that we created in the text. The button is going to be equivalent to the button that's also on the XML interface. The label is going to be the input label. There's also our edit text that's on the interface. And then we're going to add the listener. So spinner.set on item selected listener, add it to this. And then we're going to load the data. So how do we do that? We load spinner data, which is our method. And we're going to see the method down here. And here's our method down here. I'm going to skip and go back up to the rest of it in a few minutes. But the load spinner data method is going to take and create a new database handler database, which is going to be equal to a new database handler get application context, which is essentially this. It's going to give us back our context. Send it over to that object we just built and used it. So we can use this in any application we want that's going to add something. We modify it, add 2 instead of 1, add 3 instead of 1. This is only going to add a label. This is going to only add one item that we stick in that box. So then we're going to have a spinner drop-down element that's going to be created from that. So we're going to use the labels that is going to be another string, same actual labeling that we're using in the database helper class, to database get all labels. And then that's the method that we're running from the database object that we created. So this method exists in that, and we just went over it actually in the database handler. Then we're going to create an adapter for the spinner. So adapter, array adapter, common Java string adapter here from data adapter, we're going to call it. This again comes from the collections class. It's going to be equal to a new array adapter for strings, and it's going to be equal to this one here. This, because it's an array adapter, which is equivalent to the spinner, we can have it equivalent to the layout simple spinner item that we have on the layout XML. It is an array adapter. It's equivalent, so the assignment works. And then the labels. Well, the labels are going to be of the string list. That's also compatible. And then we're going to have a drop-down layout style here. We're going to set the data adapter dot set drop-down view resource. Make it so it's opened up and dropped down so we can see more than one item in there. And then attach the data adapter to the spinner, spinner.set adapter to the data adapter. Now up here we see the helper for the on-click. So we have the on-click listener that we're setting on the button. When the button is clicked, we're going to create a string out of the input label get text. And then if we're going to trim it, actually, label trim.length is, if it's larger than 0, there's something in the text box after the user pressed the button. If there's something in the text box, then go ahead and make a new instance of the database handler, because we're going to need to add this information from the get. This is the same call we did up here, actually, in the onCreate. Insert the new label into the database. Insert label, that's the method that we saw, that we looked at, that's going to go ahead and run the SQL command to insert the database. Insert the label. Make the input field to blank. This is kind of, user friendly. Make it empty again. Hide the keyboard. Input method manager, IMM, input method manager here. Set the get system resource, input method service. It's just like, get rid of the keyboard. Get it out of the way. And then hide soft input from window. It's just going to be a generic method that we're going to run to hide the input keyboard. And then load the data into the spinner. So load the spinner data. And let's put up a toast message that says enter a name label, because we didn't put anything in there because of this if up here it says that it's empty. So it's not larger than 0. The length is 0. And then on the, we just did the load spinner data method. And then the last one down here, that's the one we just did. Okay, good. So we covered it all. And then down here on the bottom we have the nothing selected, which is the generic prototype that we need to put in because we're extending this, we're implementing this interface, and the interface that we're implementing requires that for the on-click listener. Excuse me, on item selected listener has that other method, but we're not necessarily going to use it. So what I'm going to do then is see if this works. Actually, I'm going to cut and paste the entire file contents and stick it in my main activity. Hopefully this will cut and paste properly, so I don't have to type any of that. Then I believe I'm also going to have to load up my VirtualBox. So main activity. If you've called it, should be called main activity. Actually, let's see. Now we're going to have to set some includes, it looks like. So let me go up to the top. Create variable name spinner. Alright, what happened here? Spinner element spinner. Why are these? Let me just check a look here. Hold on. Did I not create the variables? Let's see. Nope, I have some line returns is what the problem is. So let me get rid of the line returns. Or lack of line returns, let's just say it that way. Put in the line returns. Okay, so now the, oops, put this back here, another line return. So that formatting, auto formatting doesn't always help, does it? Is there another one down here?
Yeah, there's 2 more lines.
let's see. Yeah, labels. Where's the?
But labels is in the top, the list.
Mm-hmm.
Data.
Button, data adapter button. Yes. Let's see. Okay, there we go. Thank you. And this needs to be back up this way, I believe. Nope, 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 no. Plus label. There we go. Okay. Say that one more time.
Spinner item.
Spinner item. Where we got? There's something commented out. Oh, yes, 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 yes. Thank you. Anything else? Oh, perfect. So you guys probably had to do that yourself a few minutes ago. All right. Let me go ahead and see if this works, actually. So I'm going to go ahead and load up my VirtualBox. I'm sorry?
You can format it.
Oh, format it now? Okay, I'll do that now. So. I'm sorry. Command, what is it? Command Shift F? F, there we go. What were you saying about saving? It's okay. When I run it, it'll save. You don't actually have to save it and run it. You can just run it and it'll save. Yes? Okay.
It's on create method.
Mm-hmm.
It's actually creating table.
The onCreate is creating the database for us.
Yeah. So database. Yeah. So I mean, in the database we are putting a table, right?
Mm-hmm.
So whenever we open the application, is it going to be called?
Yes.
So if you create that many table, it will create table that many.
Let me take a look here at the code that's in here. I believe it's not going to keep our persistent data, but let's just take a look here on create. It probably will come back and return an error if it's already in existence, but we'll see what happens.
We are not using the keyword
If not exists, correct. So it will probably replace it every time we load the app fresh. Not the best design. Well, if you want to keep the data. I have another one that keeps it for you. So, yeah.
And second question is on update.
Okay.
When
that we didn't actually call it. In this example, we're not upgrading it. So it's in there, but it says it's a generic helper, and we're not really using it. So.
Does your check actually exist? Because it calls the table. If it exists, then creates the table.
Is the code in the onCreate for main? Check it first. Let's take a look.
that has to be checked, otherwise it will fail, right? What to drop if it doesn't exist? But my question was something different. How do we know, like, if we are going, we are not calling it, I know that.
Mm-hmm.
But suppose if we have to call, we cannot just take a risk of dropping the table right away. We have a risk of losing the data.
Correct.
So what do we do?
Normally you're going to check to see if the database exists, and if it doesn't exist, create it. Or check the version of the database to make sure the version matches the version that you're working with. So when the app loads up, it's going to check the database, check the version. If both match correctly, leave it alone. If one of them mismatches, like it's the wrong version, then on an update, it would actually recreate it for you. But if it doesn't recreate it for you, or you don't put that code in there, then you could actually just drop the table and recreate it. But you probably want to export the data out or warn the user they're going to lose their data.
Actually, essentially what I'm asking is, like in database we have alter table command.
Mm-hmm.
Don't we have that?
We do. You could put an SQL query in there to alter on an upgrade to alter the table instead of dropping it or removing it. You could alter the table. Everything that you can do in SQL, you can do in here. Taking a look here actually to see. I don't actually see it checking to see if it exists. But let's see what happens. So if I run my example, which should be working now, although I did have to comment out some code that was in the, I had the same problem with some word wrapping going on in the
Since
onCreate.
it's from the open helper, right? And there is a method from the error, so obviously it should run.
We'll take a look here. There we go. So my inference loads is probably a good sign. So I'm going to put in here test 1. Oops. Get my mouse to be captured correctly. And my button's not working. So what I'm going to do here then is figure out, because I just noticed I had some uncommented code. I had some comments that created some problems. So I'm actually going to go to the solution file and change the implementation to match, because I have a strange feeling I have commented out code. So, which is one reason why I provide the projects. So I'm going to load this one. Actually, I'll just load this one instead. So this is the finished project that has the correct, from the cut and pasting, has the correct comments spacing done. So I'm going to go ahead and remove it completely, actually. And I'm going to actually delete it off of my system here. And then I'm going to import in the solution, which should work. Oops. Not export, imports. Is it doing a check automatically on the create? Is the method itself doing an auto? Yeah.
We have read the SQL.
Yeah.
The SQL.
It's all in the design of the SQL statement to get the logic that you want. And you can update, alter the table. Any standard SQL statement should work. Okay, let me see if I have any better luck with this one. Test me. Whoops. So you selected test me. Let me add another one in here again. Actually, we're not setting the label, which is interesting. We have to set the label this way, I bet. No. Well, I didn't implement that part. So it's missing that part. You're missing the label implementation. Test me. Selected. Okay, well, most of the functionality is working, but now I'm curious to see what would happen then if I remove the application. Well, no, actually run it again. Let's run it again. This one was what called database, I believe. Should be. I loaded the sampling because it's this one here actually. So the database is still there. The information is still there. Say that one more time. Let's do it this way actually. To make sure, I'm going to shut down the emulator and bring it back up. Which is equivalent to turning it off. Huh? It's installed. It's installed on there. So if I believe there's a, let me just shut it down this way actually. I think there's a shutdown. Settings. Or did I put it on the, I believe there's a shutdown. So is it inside of settings? Let's see. No, let's just do it this way.
There's a force.
There's a force. Force. Manage applications. Sure. Database. Force stop. Forcing your application cause of a. Oh, that's okay. So it's
So you have the
stopped.
clear data.
If I clear database, it's going to clear. That's not going to be a good test. I don't want to clear the data. But it is using a database, so I could clear the data on here. Let's try it now. The application should not be running. I could also reset the.
But we expect that data what you answered should be saved still.
And it's still there. Yeah.
Right. That's what
So it is going to save it persistently. I don't believe the create will work. The create's going to fail if it's already there. You can't create it unless it's there. Or did we add it? Let me take a look here. Maybe we're not calling the create. Refresh my memory on this.
When we
Yeah?
when we redeploy, what will happen? When we redeploy, will it
When you redeploy,
It's to that application name.
it's still the same application name is going to be updated.
it's going to be a refresh the database, right?
If you uninstall it, install it again, redeploy it, and that would be this case actually right now. If I were to run it right now, the data should be gone.
Yeah, exactly, because it will come up with its own database, I guess. I mean,
The onCreate is going to create it again. This is still running. Let's see. Hold on one second. It's already installed though, so I don't know if this is going to uninstall it. Depends on how we're running it. Let's see. Let me just run it fresh this way. I believe it should. No, it's gonna. It's
Yeah, it
still
should
keeping
keep.
it because the database is still. It's already installed.
exactly.
So here's a. If I uninstall it, it's gonna go away.
Yeah. When you uninstall and
So can you
redeploy,
try the version, database version, different version?
Excuse me.
Can you try a different version for the database? Just so please.
yes.
Ah, let's do
That
that.
is good, yeah.
That's a good. That's a good. That's a good test here. So let me go back into main.
Handler.
Oh, it's in the handler. Did we hard set it already?
Yeah.
Was it hard set in the handler?
Yeah. That's fine.
And you want to insert some other, just some other value.
New one.
Actually, it should. That should already trigger something. Because this is going to be a database too. On the context database version, it's not going to exist. Actually, I'm kind of curious now. Let's just try this. This is going to be database version 2. It doesn't really matter if the data inside, it's the database number we've changed. So the version is now set to 2 instead of 1. It's blank, yeah. So it's going to create a new one because it's not the same version.
Yeah, because
Yeah.
the code is written that way. We are just dropping the table.
Correct.
Yeah. We are not
Actually,
preserving
if I send it back to 2, if I send it back to 1, 1 should still be there, I believe. We didn't do anything
If you
to
send
it.
it back to 1, it will still not get the data back, I suppose.
I think it will actually. It should still be there.
It should not, because it has dropped the table and recreated.
Oh, did it? I didn't take a look at it. Is it dropping the table?
That's what I think
Okay.
Upgrade does it.
Upgrade actually would have dropped the table and then
Okay.
it would have recreated.
Very good then. I have to drop the table. It's dropping the table.
And it would have lost the data.
Correct. So the database is gone now. So this is version 1. It's gone. So it did drop the table. Okay. I had to refresh my memory on what this was doing actually. So on the upgrade, it is dropping it. Yeah. I think it's running the database create database. So it's creating it again.
It's up to us how we want to handle that.
Yeah.
But my
Now the
question was-
create isn't going to create it again if it already exists. I believe it's going to error out.
Yeah, I mean,
Yeah, because it's an upgrade.
ideally that should not happen. We should alter the table, but it is not written in that.
Correct. You could alter the table instead of dropping it and recreating it.
So this is the place where we can play around.
Yeah. Yeah, I mean, the example is definitely limited in terms of its functionality, but it's designed just to show you basically how to create that table and how to work with it. So I actually have a couple more. Oh, you have another question?
Yes,
Okay,
actually.
that's fine. You can talk while I set it up. Yeah.
Yeah. So when we have an application created, so it,
Okay.
and the database connectivity is there,
Yes.
and we deploy it to a device,
Mm-hmm.
and the device has the application. We start running, and we start building our own data, and it starts saving it. That's done. When we come up with the we do something, we change something, or we do not change anything, and we redeploy it. It's a We are not rerunning. We are redeploying it. So when we are redeploying,
If
we are
you
not coming with the data.
redeploy it under the same application name
Mhm.
with the same signature
Mhm.
and you're going through the same market program,
Mhm.
it's going to think it's the same. So it's
Okay.
not going to replace it.
You just take that.
It'll just replace itself with the newer version. If you're going to deploy it as a brand new application, change the name. And it'll install itself. Just like in here I have database 1 and database 2.
Mhm.
I have two versions of the same one in here. Because a few minutes ago I decided to trash this one. So then I decided, well, if that's the case, then I'm just going to load this example in. So let me just trash that one right now. So I don't have it on here. Oh, it didn't do it.
No, it's you have to delete it. That will not remove it.
Ah, you're right. You're right. I have to delete it. Yeah. But it should, to answer your question, it should deploy it as a separate application if it's a separate application. If not, it's going to replace the application that was there. If the database is already there, I believe it should keep it. It's like we redeployed it here by reinstalling it again, and it kept it because it was already there. It just replaced it. So I guess, depending upon how Google Play updates, you could probably set options in there. There's a couple of options you can actually set for how to handle upgrades and stuff like that. So you
Because
basically have to research it.
In my
Yeah.
phone, when there is an application, I get an alert, right? And it says that there is a upgrade available. Do you want to install it? So I believe possibly there is a code which keeps the version checking, and then it calls that on upgrade method sort of, and then it actually preserve the old data and alter the structure, and then brings me up the data, the old data in a new structure.
It
This
is
is what
possible. It is possible.
But suppose if I choose, okay,
Mm-hmm.
I have that application already in my system, and I go ahead and try to install it again. Since there is a provision, it says that it's already installed. You need not to install. It says that is another thing. But suppose if we forcefully deploy it, so we are going to lose the data for sure, right?
If you forcefully deploy it and overwrite everything, then you're probably going to lose the data.
Lose the data, right?
The data is associated with the app and the space in which the app is occupying. If you remove the app, you're removing the data.
Exactly.
So
Is there any limitation on the space?
there is, actually. And the limitation, I believe, is set for the same limitation as the app, and I can't remember what that is. If you go online and take a look, you probably could find it. What is this? So constructor object is undefined for default constructor must be defined. An explicit constructor. Let's see. Why is the utility going to do that to me? There's another example, however, I don't believe we're going to, well, let's see where, I probably could fix it as I'm going through there. Okay, so I have another example that I'd like to show you, but when I loaded it in, I'm getting some interesting errors that are coming out of it. This example is what I call the legacy one, as I was mentioning before, and I can go through it without, let's see if I can get my internet access back. I can go through it without compiling and running it. You probably can see what I'm talking about. If we looking for the code, it is located in supplemental notes. So if you go into Android phone application development and go into the supplemental notes section, in here we have one that's called database examples, database example, right here. This is the one that's going to essentially be the same as the one I've got on the screen here. But I'm looking at some interesting implicit super constructor object is defined for default constructor. Let's define an explicit constructor. Looking at okay. looking at some interesting errors I need to troubleshoot in order for this example to work. However, the part of the code I wanted to show you was the way that this is put together. Actually, let me save this sucker. I believe I changed it as well. So we're not going to have any luck with that. So what I want to do is just show you the way that it's because of this depreciated library, I bet. Yeah. It's using an old API. It's an old example. We're going to see a bunch of depreciated problems with this example because it's extending classes that don't exist anymore. But long story short, what I want to do is show you the SQL code and the way that the project is assembled. So the main driver program here is our database demo class. The database demo class is using, again, this one's called database helper, but it's the same concept as the database handler. And it's using a grid view and a text view. It's a slightly old program. And it's running the database helper. So the database helper here is an example of it being, again, another way of setting it up using SQLite open helper, which is the same technique we saw a few minutes ago, but it's a bit more elaborate. So we've got the table name, the database name, column IDs, department IDs, and things of that nature in here. And it's a little bit more detailed, a little bit more information, slightly different implementation than the simple one we just looked at a few minutes ago. You'd have to modify this one to update the libraries on it to get it to work. It's definitely having some project issues. But we can see in here we have a create, and we have this table, we have create this table. We have a create a trigger. So what it's demonstrating is the creating a view, the use of all of the different database techniques. So as you were mentioning earlier, we could just do an alter table. Like you can do an alter table. It's just the same way as you can do a create view, or you can do a create trigger. If it's a standard SQL statement like alter table, change this to this, add this kind of thing, remove this column, it works. And you would just basically line it up like this. And this is on the on create for the database itself, for the database helper. And then we also have the on upgrade, which we're dropping these tables again, dropping triggers, dropping views and things. Don't necessarily have to do it that way. This one is just basically removing it so that the onCreate can recreate it for us. If it's an old one, if the version doesn't match, and we have the old version versus the new version. And the new version here is going to be set up programmatically, it looks like. So it's going to be essentially just looking for a change. And so this one's also broken out into a couple of different helper classes as well. As an example, add employee. So add employee is going to take on create here all of the different items that are associated with the add screen of the application. And then it's going to set up a simple cursor adapter here and use the cursor information. And then it's essentially going to do a little bit of exception handling as well in terms of being able to check the button activity on the click. And on the click, it's going to add the employee by using the DB helper again and running an add employee from that object that we're creating. So it's nothing more than dissecting out the functionality into different classes and then using the classes inside to separate out the responsibility for each one of the functions. So we can have a delete employee, add employee, set up an alert, which is the way this one is structured. So this one, however, is what it's working off of. Let's see. It's got issues. It's working off a very old, probably 1 point something API version, and it's using some non-standard stuff. So very old code. However, it does a good job of showing you yet another example of dissecting it out. Break time, or do you have a question?
Yeah. When there is an SQL error, how do we handle that?
If it's not caught by your query and you're not doing any error checking, which this one actually does do, which is kind of interesting. If you're not testing it, it's not going to be caught at all. It's going to be like any other error that occurs in your program. So it's not a bad idea to actually check to see if the query results actually came back, or we actually have a result set, or we can go next before trying to go next. Yeah. So it's left up to the programmer to answer your question. If you don't do it, they're not going to be caught. and you're going to have some really weird functionality going on in your program.
Do you think it's better to use a ORM tool to automatically generate query?
No, I would write the queries in your program using these query execute statements. And I would not use a third-party tool for it. I know that there's a couple of them out there, and they're like little Android projects, and but they make a lot of code, and they're also prone to mistakes as well. Hard to debug. It's so simple just to create the database objects, and in fact, you don't have to create the helper object. You just put it in the you can just put it in the code if you want as well. But most people will separate it out because it doesn't really belong in the main activity. It's the database. So like you make a separate class for the database helper that's going to create the database for you, that handles all the database connectivity. And then you have a separate one, let's say for the UI, and you have a separate one for the file I/O, and you have a separate one for all of the other pieces. So, rather than keeping it all, if you put it all together in one class, abstractly it gets kind of difficult. It gets kind of difficult to look at as well. So, all right, I think we're due for our first break. So I'm going to stop this video.